All right, testing, testing. Let's just check YouTube and see that we're on. We're currently streaming. Doesn't say that we are. Twitch seems to go up, but YouTube does not. Oh, there we go. Okay, cool. Let's just grab that. Need to edit that, but I'll come back and do that later. Okay. Right, where do I need to grab the link from? There must be an easy way of doing this. Copy link. All right. Okay. Just wait for some people to join in. Right then. How are we doing? Users, Boss and D, hey Dim. You're a real person or a bot? So I always want to know. Right. We have coffee, tea and water. We are set. Can you see that text? I'll make it a little bit bigger. That'll probably do it. Right then. Just messing with my lights at the moment. Okay. You never saw that. No peek behind the curtain here. Welcome back as we delve into the scariest place that you can ever go, your old code. Ooh. Today we are looking at expression evaluation, which is one of the hairier sections of WhiteBox's code base, and we're just gonna have a look at making it more stable, making sure that it's correct, doing some property testing, possibly adding some interactive views, and continuing what we did last time, which involved adding a new UI element where we could inspect the any arbitrary expression that we could build up bit by bit. So we can take D, and because D is a pointer, we can dereference it, and we can ask for the particular samples, or we can look at all of the samples that it's got. And the reason that this is all the changes that it goes through. One of the things that I want to make sure is that it's actually consistent across these, because I'm pretty sure there are points where these don't match up. So this is just the pointer itself, and then the dereference isn't added at this point, and we have to click plus to add it. I might change that, but it works at the moment. Just a debug tool. Just an internal debug tool, not even a external one. Well, we've got 6 people. Who has joined? I can't see any users in chat, but it says we have 6 people. So, hello, people. This is what we did last time, built this expression builder. And it occurred to me that we could just do a stupid thing, do some simple stuff. Yeah, Ben, how you doing? Top of the morning to you as well. It occurred to me that we can just do a slow assertion that goes through every sample and checks that these are actually correct. Because currently we get occasional odd artifacts. Now I can show you that with this. Change function to this. Now, if we have a look at D, dereferencing it, for some reason we get no data here, when we should have a valid pointer. And you get weird things like if you actually reference it, it becomes visible. And also, we know that we've recorded it because it returns a pointer to this data, which auto-evaluates to 6. And previously, when we looked at the expression builder, which for some reason is not showing anything. Oh, right, I know where that is. I will fix that in a sec. When we looked at the expression builder, we could also find data. So first of all, let's go into yeah, we shouldn't actually be looking for this. We should be looking for the primary function rather than the top function. And I'm pretty sure we do that fairly frequently already. This function map. Yeah, there we go. So if function and function object, then function object. Cool. Hot reloading's broken at the moment, so let's just rerun it. So we have the inspect expression, that was fine. What's wrong now? This is the other thing that that is broken in, I think, exactly the same way actually. Okay, so we'll make sure we have the object there. Recompile that. Right, so we run this. We can inspect the expression, fine, change location, and we still inspect the expression. Cool. So if we change that, then this updates and all is well in the world. So we'll just change to our D variable and we'll dereference it and add that to the stack of expressions. Hey Bill, how you doing? And so we can step through and see where we have data. And clearly we can see that this expression change list isn't correct, given that at sample 19 we actually have some useful data. Keeping well, just thought you'd drop by to the stream. No, thank you, I appreciate it. You are always welcome here. What are you working on? So you're doing some like LLVM debug stuff? I don't envy you. I also need to do some at some point, and I'm not looking forward to it. Yeah. So let's just do something really stupid. Not stupid in a bad way, of course, just regular or stupid. So actually, don't need that for the moment. We want to look where we're using this, and no, let's just go back to the our expression inspector, and here just gonna add a simple loop. We've got a function expression eval. Changes. I'm sure there's a better way of doing this, but this is easy enough for debug stuff. Zero documentation on even less than normal LVM stuff. Super helpful. Have you been looking at the IR textual output as some kind of hint to what's going on? Like all of this fun stuff. All of these debug information things. That's how I learned LVM in the first place, yeah. Alright, so we're going to look at all samples in total, which is basically just doing this. Yeah, we'll just do that lots of times. And we'll just call this inspect eval x per sample index. Alright, so we're on sample index. We're going to want, just going to take the function object. And the expression. Right, let's see whether that works. Data size, yeah, okay. Function object, give expression, data size, that one. Just size 0 to sample index 0 to function object run data dot samples array like and needs an expression string. I realize we probably could reevaluate that, but we're doing it quite a few times, so let's not push it too much. Okay. Right. Let's get rid of that. Declaration samples a local variable. Does it now have that? Pointer. Expression string. Cool. So let's have a look how that runs. Oh wait, we want to go back. Right, quit this for a sec and just re-enable it so that as soon as WhiteBox opens, it opens this expression thing. So we'll turn that on. Okay, and let's open up again. There we go. We don't need that extra thing at the end. Right, let's change that to D and dereference it. Okay, that would be why. Could I actually pass the right thing? Funny how that works, isn't it? Dereference add. And also, just for the sake of being like super clear, let's change all of these to ints. What don't you like? Well, yeah, I did change it. It is no longer a double. That would be why. I don't really want to deal with you at the moment, so let's just continue. And yeah, okay. So is a very clear pattern here, at least it seems to me. We have no data for a bit, and then we have some garbage data, and then we have the single value that we actually change it to, and that never changes. So clearly our change thing is not working properly. Just while I'm messing with stuff, let's change %, not 3. What did I do? Percent not 3. Oh, no, wrong one. Cool. All right, just make stuff line up, which is nice. And hopefully that all agrees. It looks like it does. Okay. Hey Skytrace, how you doing? Welcome to the stream. So now that we've got this, and we've seen that it's different, let's add some assertions to get it to trigger if and when that breaks in the future. Which is what I was starting to do here. Right, so we have this tree with, well, I guess it's technically kind of a forest where each variable is a root. And so we iterate through this tree, and for each thing in the tree, we want to see whether the expression holds for all samples. And by expression holds, I mean see whether the changes occur in the supposedly faster way of doing it compared to just doing it at the naive look through every sample way. Data tree next, I think is what I want. Or do I want GUI data tree next? I think just data tree next will do it. We want an empty data tree, I think. Oh no, function object data tree. Yeah, I want to use that expression. But we want to clear it first. All right. Okay, so we'll go through each thing on the data tree and let's have a look at what data is in the data tree. If I can type. Okay, so let's just dump the data it dot expression string full, and what are we looking for here? We're just operating on the expression, really, aren't we? So let's should we just make a simple array of yeah, let's just do an array of samples when things change. Samples. Change samples and then at the end we will just pop back to that address. Okay. Yeah, let's just do it stupidly, okay? Same as we did before. For a range, size, don't want that for a moment. Sample index 0 to just get a samples n, then run data samples. Samples n. That's sample index. We're just going to do data it. This is a pointer to the whole thing, and that's a double pointer, so we need to dereference once. So we're also going to want to actually push some data. So let's do that. I'm actually just going to change this to be, and just do it as a malloc one. Because I don't feel like handling that at the moment, because this is debug stuff. So because we're going to use the arena in here, push so evaluation expression gives us an address, and then we can get the value for that. We've got type size here. We've got array n. It type. I think that's correct. Actually, let's just do single values for the moment. So we want to evaluate the expression. We get an address, and then we use that address to get some data. And we're going to have to do, we're going to want two of these, aren't we? because you need to have one for now and one for comparing. And we'll choose which of those we're using with the data index equals active data turned data array length of change samples and 1, so just modding 2 basically, and then comp data is okay. So we'll move that into active data. We've got our sample index, we've got an address, we have a run data. Okay, so if we want to know whether the previous one turned okay. If sample index equals 0 or interned okay is not equal interned okay previous, or or memcomp active data comp. Come on, I think my file's getting too big. Vim doesn't like it when they're over 5,000 lines. Comp data, we're just using data equals if that's the case, then we'll push onto our change samples sample index. So that's one variant. Data size. Okay, I think I'm gonna have like that much is gonna be one variant, and then the other variant sample by sample by next. Next. There's at least one good. Yeah, that one. To function obj, take the arena and make sure that we're not leaking ridiculous amounts of memory with interned data 0. It's the first one, so we can just pop back to that and ignore the other ones. GUI elements expression. Just make sure to clear it. Put some debug printing in here. Just do the value. So we're going to put eval expert string. Is it expert eval string? What is it? Oh, expression val string. And let's put it on. Oh no, I don't need that. G global scratch push, and this is Bill's idea of a massive ring buffer in the sky that you can push data on, and it's mostly useful for just for temporary strings. But I have a this like push abstraction that lets you use arenas and ring buffers in the same way. Um, mm, 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 mm. Options, function, no, function obj. The address we've got there. We have active data. We have the sample index. And we don't care about any indent, so that's fine. And then if it changed, we'll just print changed. I guess we need to put that later. Right, data size. Oh, we're already pushing that. Okay. No, we shouldn't actually be pushing that because this goes through the entire thing. Let's type string. Whenever strings are generated, they're both a length and pointer, but the string itself is always initially 0 terminated. So if you're just immediately going to use it, you can pass it into printf like that. Val. Believe that's what's needed. And let's just export it. We're just going to make a separate change samples. Just have two of them. It's the easiest thing to do. And change push into this one. Export it. Run address, expression iterator, next index, expression count. Sample index. Index equals 0. Sample index. Don't want that. and we'll actually do it into the middle of the array rather than treat the array as its own dynamic array, which would corrupt everything, and we'd all be very unhappy. So, the obvious next thing to do, once we've done those, is assert that array length of change samples 0 equals array length of change. Being able to type would help. Change samples 1. Assert that memcomp change samples mem equals change sample 0, change samples 1, array size. Okay. And then we just want to call this from somewhere useful, like just after the thing has run. So let's go to gap.c, run. Okay, and let's run this, and hopefully it should fail. Promising. Okay. Right, I'm going to fix that in a sec. I'll be right back. See you momentarily. Hello, I am back. Right. How is chat? Right, I guess we just got to push the variable into here. Like I said earlier, we kind of got a forest of variables, so this assumes that you've put at least the first thing on there. Expression is function of expression. Now, oh no, I don't want to be clearing it. That's my issue, I think. And let's just wrap this in. Maybe better to put it there, actually. Okay, so we'll put it there. We actually have the function object now, so we don't need this function. Okay, so. I was in the process of taking out that clear. And now we're going to recompile. Gotta love a good recompile. Wait, no, I can't say that if I'm marketing WhiteBox. But I hate good recompile. Gotta do it all instantly. Right. Did that not run? You think that you're not going to get found? Did not compile properly. Oh, I've just realized something. If I'm in Remedy. No, yeah. I wasn't sure if it was switching to the wrong screen, but that's fine. If debug info, that should be on. Okay, let's go to app.c and check. Wait, did I put n0 like a Muppet? I think I might have. Like an absolute Muppet. Okay. Okay, let's recompile. Run. Cool, cool. Let's just see whether we hit the thing. Okay. Something's going on there. Okay. Right, so we're going to rerun. First of all, let's have a look at our data iterator. The fact that this does not have an expression string is not a good sign. Interned OK was false. Address is... Oh no, it has an address. Whatever it is, but it's not. Expression, variable 0, subvar index 3. Okay. So, type size 0. Yeah, that's not really great, is it? Right, let's just I'm only doing that there. So oh, I think that might be in the GUI debug next, and it's just in the same struct. That's fine. Let's do that. I will make a reference to dwarf die star dies. This is the problem with having an index-based system, is that you, rather than using pointers a lot, because it means you need to keep passing the arrays around even if you're only ever referencing like single things in it, which is quite common. Or at least in this code base it is. So like just scattered around in so many places, I have dwarf die dies equals function of dwarf dies. And it's not like it is a lot by itself, it just adds noise that really it would be nice if it wasn't there. And it's just a little bit of a distraction every time you have to write it. Okay. So we've got that, and that will do from scratch. So expr val string g. Oh, it's just this, isn't it? No, not val string. We don't want the val string. We want eval. What's that called? Expr full. Okay. Function, object, and expression. Full. That's just going to become data g scratch push function object and function object expression. Yep, take a pointer. Okie doke. Alright, we are up and running. Hey, we got 9 people on the stream. How y'all doing? So we're gonna open up Remedy, rerun this, and see what we get. See if we hit an assertion, which is kind of the first thing we're checking. Cool, we did hit an assertion, and that's what we were expecting, that the lengths are different. Okay, let's just see how many changes we expect for each. Well, those are a bit different, aren't they? And it might help if we actually set indent OK previous to whatever. That might be part of it. Always got to make sure when your test code fails that it's whether it's the thing you're testing or the test code itself that's wrong. Okay. What's that now? We actually didn't break. That doesn't sound right. What you doing not breaking, huh? Alright, let's have a look at the output and see whether there's anything there. Right, let's put a little bit more information in this. So we're going to do, what is it, like out intern data or something? We want 3 things. We want sample, so at send 03 ZU. We want the address, send P. So sample index, addra.proc, addra. So if we don't have data moot, we use hit intern data. Okay. Dwarfs it out. Function object. No function object. Intern data. What want here? Do I want a subvar? Or, yeah. Whatever. Very last. Yeah, take the type of the expression is the last thing on the expression. And so we take the subvar from that. Sample index is there, offset there. Okay. Okay. Right, someone's okay. Sorry, someone talking to me. Let's recompile that and come on, rerun. (442). Okay, let's maybe make some new lines for those. We want this. Again, sample index, and then expression it dot addra dot proc addra. I'll just put the thing up front there. That's fine. Right, and that's fixed. So, we run again. Got way too many things open. Garbage goes to 6. So D changes from, okay, yeah, so it changes at 4, that's right. It's correct that it's not changing when the dereference value changes. That should only happen on the dereference level of the expression. But we're not iterating to that dereference level of the expression for some reason. Ooh, data tree next should be getting there. Unless I've missed something, which I probably have. I think I might have like a... where is it? I think, yeah, it's expand. Data tree. And we always want it to be true. We always want to fully recurse, not just do the top level. Okay, so looking at this now. We are actually looking at star D. Okay. Cool. So I'm a little unsure about what's happening here. Like after the address is changed, why is the garbage values like the previous value still there? Anyway, that's for another time. And like, what is this? So we have a am I doing those asserts at the right time? Because I might not be. Funnily enough, I'm not. I'm only looking at the last one. Array reset. Lang. Change sample 0. Change samples 1. That's more like it. There we go. Also, like, why is that different? Those values seem the same to me. jump in here. Oh, that probably went from changed from is not valid to is valid. Let's add that because that's actually quite important. Eval next. It dot kind equals dw no expr op kind inaccessible. Or let's do the positive one first. Address. Otherwise, we're going to do just going to say not valid. Oh, no, that's the wrong place. Sorry. So if the expression up is valid and it's an address, which is the only way it can be valid. Otherwise, just print not. Do what you do everywhere else and just put no data. I think this needs compressing because it's in a few different places. Okay, just temporarily disable that. Okay. Just disable that. Okay. Ah, interesting. Okay. No day for both of them. Right, change symbols. Yep. So we have 3 versus 2. So and they're at different addresses anyway. I mean, different samples anyway. Bad food, bad food. So we got any more tea? We do have more tea. Excellent. So let's do it actually at the time that we're pushing. So we're going to say here, just after printing, now we want to say that the one that we're currently doing doesn't get bigger. And we want to assert that Rayla that I equals that they're the same index there, right? Okay, and then that should get triggered at the time that it actually changes, and so we can have a more of a squiz of what's going on. And I might change my assertion to not bump up that message box because it's happening quite a lot and it's getting annoying. Is 1, yeah. So, so I think, one second, I'm just going to lower my standing desk a bit. Have a sit. Let's get that camera. Okay. So I previously mentioned that I would be ignoring the fact that this is the case, that we have the same value for 2 samples even though the address changed. And you can see that the change for each one, the change for sample and the change for by going by next is different because of this, right? So if this were actually the case, which we could check. We can check that by outputting everything as we intern it initially. Although that assumes we're interning correctly, doesn't it? And at that point, why doubt this? Is there somehow... Is there like something happening on another thread when memory gets allocated that it's not actually, the page isn't actually made accessible until a little bit later? because otherwise I'm not really sure why this is happening. If it's accurate, that is. Like, you'd think malloc would get some memory from the system, change the permissions to make it accessible, and then give you the pointer. Whereas we're getting a pointer, and then we're later able to actually look at it. Okay. Let's just output when we intern and see whether we're getting anything different. I have intern return value, intern data. It's app x86. Intern data. Where is it? Intern.c gets called from app132. Okay. No. Gets called. What? Is that that can't be the only time we call intern data. Unless it's just a different variant. Page load data. Right, what functions have we got in here? Intern range at sample, that's what we want. Yeah, that's what we want. Cool. Should do in app.c. And here we have this. Debug data printf. Get rid of that. Recompile. Right, just close a couple of things. Don't want that, don't want that, don't want that, don't want that currently. Okay, so, well, let's have a look back. That's got way too big. Okay. Can I search in this? Find, I can, cool. What do I need? I want D is a little bit too. Alright, fine. Okay, so 11,352 FT60. Is the address for the pointer, but we want the actual address of the pointer. 14 AOC3D. 14 AOC3D. That's weird. More tea needed. I'm gonna stop using. I know this seems like a little bit of a tangent, but there's I currently have this thing like os.can dereference memory, and it basically checks whether the pages should be accessible before trying to read from them. However, there's not really much point in doing this, because when you try and read from them, you'll just get an error if it's inaccessible anyway. So what might have happened is that I'm checking, like, can I access this much data? And some of it's valid, some of it isn't. And I'm asking for a range that just is partially available. And if that's not all available at once, then I get none of it, rather than just the bit that is that's actually valid. So perhaps we should do that now. It's something that needs doing anyway, so why not, you know? Let's get rid of this for the moment. I'm also not entirely sure. It was showing that it was trying to read from address 8, which is just kind of weird. And it's something to come back and have a look at. In fact, we don't really want to be doing this like intern ranges anyway. We want to like find all of the ranges I think what we want to really be doing is marking every page as going through all of the data that we're collecting, mark all of the pages that we need to record because of those, and then just save those pages, rather than doing this like old method that I had when everything was really piecemeal. Yeah. It's going to be a little bit of a moderately sized change. Okay, well, let's get going. Right, so we have not that, sorry. So we've got this function that I mentioned before, which is data tree next. As you can see here, we have a to-do, which is use and recording as well. And that is exactly what we're going to do right now. Interning. Just see whether that broke anything. Right. Expert check. Expression, evaluation. Let's just move that whole thing into app. It probably should be there anyway. Before I do this, I'm just going to get rid of all of the other changes that we have. Otherwise, they're going to get too mixed up. I mean, and by get rid of, I mean commit. Git add -up is the standard way to go. Inspect eval. We don't want to leave that debug thing on. Or do we? No, we don't. Show expert. And then we have to rerun just because Git caches everything. We do want to save that. What's this? Yep. Save that. And save that. We will not save that. So what have we done? We've just add eval next. Does simple loop to find eval at all samples. And compares to eval expr next. This is technically not quite right, as expr eval next will also emit changes when the pointer for a deref changes. When an item higher in the eval stack, e.g. the pointer for a deref, changes. Yeah, that's fine. Cool. So now that we've done that, let's go back on with what we were doing. So data tree next. Files, source code, instructions, JIT management. Interning was where I put before, wasn't it? And we also wanted all of these expressions. Expression. See if that compiles. Interned pointer at sample. Pointer at sample. Interned pointer at. Is it just after I've included data intern.c? Yeah. Okay. Peak value. Now, I know what you're thinking. You're thinking, is that COVID, that cough? And the answer is maybe. My girlfriend, whom I live with, got COVID yesterday evening, so it's probably just a matter of time. But we'll make the most of being able to speak while we can. So chuck it in there. Expression val, that can go in with the expression evaluation stuff. That'll go quite nicely. Expression eval. Okay, I can go higher up in that then. Out. I think. Um, X per check. Maybe this should just be under expression stuff. Var expr. C. Cool. And I don't think anything should actually change in this, but let's just run it anyway. For good measure, we'll run tests. GUI separator, whatever. Alright, that all kind of seems mostly correct. More T. Okay, and just while that's running, let's just write a commit message, which is gonna be just saying we moved everything. Just so the actual like code changes don't get lost in within the just stuff we moved around. Yes, 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 yes. Yes, yes, yes. No. Okay. Git commit message move expression code to app.c. 666, no. Goodness. Now, if only I was superstitious. Right. So we've got data tree next. Just amend that. Tree next and expression code. Okay, so we've got a data tree. And what we want to do is we want to find where we're going through currently. So this It's just so old, there's no point in keeping it. So we want alright, so we're looking for multiple lines of comments out. That can all go. That, no. Alright. Okay, I don't mind those getting bundled up in the previous thing. Git commit, no end, and I'll just add remove some excess comments. Commented out. Excess commented out code. Okay. Always nice to reduce the amount of code we've got. So, now that hey Vinit KME, which keyboard? Sounds like brown switches. They are cheap knockoff linear reds. But I may be like bottoming them out more than I should be. But it's a soft play like split one that I soldered together on a previous stream. So it's got normal key things plus some of the thumb clustery stuff, and then it's also got this little rotary knob, which currently is bound to scrolling up and down for the right hand. Well, thank you very much. What was it in? Let's just move some of this so that I'm not falling off the bottom of the screen. Right, what am I doing? Oh yeah. Did I build it myself? I got it as a kit and sold all the bits together. Well, I got the electronics as a kit, and then I got the switches separately, and then I got the keycap separately. Out params to return value. What am I doing? Yeah, okay. So I need to find where I'm going through all of the data, and rather than doing whatever custom rubbish I'm doing, I just want to go through the nice iteration that we've already got. Intern data. Intern range at sample, intern values at address. Intern in a value at address. Internal values. interim variables values. That's what we're looking for. Okay, and that's called in app probably, or maybe in app x86, and yeah, there we go. So just have a quick reminder of what we're doing here. So we're going through each of the debug information entries, shortened to die, and we're seeing if it's something that we should be interning from. Interning basically just means recording. Yeah. And if we are, then we get some data of the location. This type die stuff. Yeah. Okay, let's do this old chestnut. Old. New. If global feature flags dot intern new dot on. New. And then we'll add a feature flag. That can be off, and then we'll just add that in the flags. Looks like a battery died on camera. Let's just replace that. Should be coming back online anytime now. Maybe. Hopefully at some point. Alright, let's just go into come on. On you come. Alright. doesn't want to play ball. Okay, never mind. It's not working. Right, just my voice for now then. So, let's turn off these lights as they're not being used. Oh, I didn't get to show you my my duck. Maybe next time. It's just a incentive for you to come back. Okay, so we're going to go through everything, but we don't necessarily want to recurse down all of the children, right? So let's have a think. So first of all, we want to add any variables. Like, so bottom level, add variables. If we want to add, so if those are within a page, we want to add that page to a set of pages that we're looking at. And if if the variable is an array, then we want to look at all of the items on the array, and would so just add any extra pages that are covered by that. And then of course the more important thing is references or pointers. And so if there are any references or pointers, then we need to follow those. And sorry, but going back up a step, basically if there aren't any pointers, we just don't want to look any deeper, right? So if it's a struct, then we don't want to look at the individual members of the struct, because we've already marked that whole sector of memory as to be recorded, because we've marked that page as to be recorded. And so we want to look, and this data.expand is basically, does this type contain any pointers? Which we can do here, or we could do somewhere else. Because we already kind of go over some of the we do like a pass through all the types to at least find the right color to print stuff on the timeline. But we could do this at the same time. Where am I looking? GUI data values. Color. TL type count, pass through certain type, die index, bool, contains pointer. So we'll have a look for type. Do I actually use this anywhere? Types, function objects, static info. Yeah, that looks right. Types, function object types. The color based on die index, array length, function object types. I'm looking for particular type index, LUV from inner types. Jet.c, cool. Type get inner types recursive. So we can, it's just really part of this. Inner types equals types. Okay, type die.tag. So point to type. It's gonna make it more prominent. Actually, no, that's fine. If it's a reference type, then we're going to want to go kind of all the way up, right? Type, inner types. Okay. Type, just making sure that this is actually, yeah, it is. Okay. Using that type and not some other indexed type. So type contains pointer. Do pointers themselves contain pointers? I'm gonna say yes. True. And then in types, inner type count pointer. Type contains pointer or equals, so like it may get set to 1, and if it ever gets set to 1, it's never going to get set to 0, or equals contains pointer base type can't a structure or an array can. That seems fairly reasonable. And then pointers already are, so there's no point in going in further. So back to where we were. Data tree it. Data iterator. Data tree iterator. Type die. These should be pointers. Would that break it? Ah, okay. So I probably could have done this initially rather than moving everything around. I don't feel like moving more stuff around. Sub var index. Oh, I don't see that then. Okay, let's just fix that while we're here. and the rest of them are just unused parameters. That's fine. So, do we want the data so far or the user so far? We want the, I believe user is, like, so if it's a reference, I guess it shouldn't matter either way, should it? Because if one contains pointers, the other one should as well. Right, I'm gonna data it dot user sub var type die index. Maybe it's in GUI. Right, where do we get to? App.c. Type index. Function object types die index. Yeah, strides are a very useful thing. I mean, you can have a single function that works for either an array of things or an array of structs where that thing is a member. and as a result, basically every single one of my binary searches is done with this single function. And it doesn't have to have a like a separate comparison function like what is it, bsearch, the standard library one. Types type index dot contains pointer. Okay, so before we do that, we want to actually do the adding a page. So as part of our function object in I think we're going to add a map here. It's really a set, but I don't currently have set types, so it's just a map of bools. I think we've already map, function map, string map, address sample, bool map. I just want do a bit of macro trickery to add a type in the template. And where do I go? To function object. Come on, where are you? There you go. Okay. Addra bool map. And this is a list of pages. Pays it to intern. We're just gonna be stupid about it at the moment and redo it every time, but we should be able to actually keep most of it the same and just look at pointers later. Addra bool map clear function object pages to intern. It's going to make an array of 1, and so we can reference it like that without putting pointer. Okay, so we want to get the I'm going to make sure that we're using the same subvar everywhere. Okay, so we're going to get the initial, the address at this sample, which we probably got somewhere down here. Address sample. Proc handle, function call address. Where do we take in the sample? Why is this not dwarf var? Var lux var index. Where is the sample getting incorporated into this? Because pretty sure it needs to be instruction index. Nope. Function call address. We've got run data proc handle. We've got the CPU data. Right, yeah, it's based on the CPU value. I.e., depending on where the instruction pointer is, it'll do different things. Yeah, so we've got CPU, we've got the, we can get the die, I'm sure. Data tree it, type die. Right, yes. Only for the actual variables. Okay. I'm gonna be back in a second. I recommend you move around and get some to drink in the meantime, and I'll see you in a sec. Hello. Oh, hello. I thought my mic was not working for a sec. Hello again. How is everyone? Right, I have some tea. Refilled my teapot, which means we're ready to go. We just pour some out. A little taster while it brews. Okay. As you can tell, it's been from my lack of familiarity, it's been a while since I wrote all of this code. So, needs a bit of reminding. And the great thing about iterators is that they can really, like, it provides another way of abstracting stuff that is different from just normal function calls. I mean, it is a normal function call, but there's an expectation that you're calling it repeatedly. And it lets you abstract stuff in a slightly different way. And so you can have a lot of stuff that actually takes up very little space. I tend to like it with this format where you just initialize some data, often with just 0, and then you call the function basically in the while section of the for loop, so it returns whether or not there's anything to process, and takes a pointer to the iterator and whatever else other information it needs. Alright, so what was I saying? Oh, okay. Yeah, we need to do the variables. Maybe just do an outer loop, which is just variables, and then do the inner loop as the inner loop is this. Each from So we'll go over all of the variables. Hey Skytrace, welcome back. And we're going to clear the expression stack. And then push the variable do I have a way of doing that neatly? Exprop as whatever. Array push function of expression, and we're going to push on expression up dot kind equals exprop var index equals var index, and sub var index equals var sub var index. That's easy enough, isn't it? Okay. And then we're going to iterate with that as the root of the stack. T. Half the reason I have T is just to have something warm to put my fingers around so I don't lose the dexterity in the cold. There's enough going on. We'll put that on a new line. Right, so we're doing okay, let's do that separately. Alright, so sorry, I'm just going to pull out this section. Update var lux. Void update var lux. So we do that. I'm going to take dw var.address. Get rid of all of those. And then varlux, we've got the varlux, varlux, var index, sample index, var index. I'm going to put that I was going to say put it here, and that way you wouldn't have two things that could alias next to each other, like where you accidentally get one the wrong way around. but because uPointer is basically the size anyway, that's not going to be the case. Index. Do I use DW-var? I do, yeah. Sample index, isn't it? How very dare you? Why is that not allowed? Oh, because it's later. Ha, that would do it. Function object arena. Right, we're not using CPU yet. That's fine. That's fine. That's fine. Okie doke. Update our locks. Function of arena. Var index. Oh, I can work out varlocks from var index. Let's just pass the function object. Right, so where we're trying to take a die here. Okay, so this is var die. Run data. Right, this should actually be run because it's run. And then the run has a back reference to its parent function object, so that's fine. Intern, yeah, function object run data. We want okay. Okay, update var locks. Alright, so this now takes the run itself, and it's going to take the var index, the dwarf address. This is kind of doing some fancy stuff, and because dwarf is a weird format, this address is determined based on an expression that is Turing complete inside a debug format. Yeah, which is super exciting. Normally it's fairly simple, and then sample index. Run data. Yeah. When is that used in this one? Is it not? Okay. Maybe I'll get rid of it then. Or maybe I should be using it. I'll just avoid it for the moment. So yeah, we can access both sets of information based on either. It's basically just kind of which is more semantically meaningful, and we're doing this for a specific run rather than just for the code that can be run as many times as you want, and so it makes sense to do it for that run in particular. Okay. Function object call address. Do you draw function direct address? And we have a proc handle. Okay, so we're gonna update the var locks. Assume we can just do this as well. Wow, this is slow. Jesus, okay. For some reason it's fine if you paste it like that, but really slow if you paste it while in insert mode. I think it's doing something with every character press. Okay. This is in the wrong place. So I'm starting to think that basically all of this is the same, and that really what I should be changing this instead. Sorry, knocked the mic there. Sorry. Oh, we got 9 people in chat. Array member subvar. What's this all about? Yeah, okay. Yeah. I'm gonna kind of undo most of that because that's all fine. But, you know, worth going over just to remind yourself how it all works. Actually, I'm not going to undo it. I'm just going to copy back. Undo. All of the undo. Okay. Let's just all the way back. Okay, that's back how it was. Basically, we want this. So I'll get rid of that. Get rid of that. And move this all above intern values at address. How would they call it? Intern new. G.ff intern new on intern values at new function object. Come on. Proc address subvar index intern n sample index. I know that's not you. It's not your stream either. Vim is actually being that slow to update. So the problem with this old one is that it does all of this like complicated recursion through a few different functions. We have these like intern inner values and then intern inner values and so on. And really that should all be covered by this recursion, this data tree iterator. Goodbye, update bar locks. You shall not be missed. Yeah, here. So you can see the dreaded can deref mem that we don't want to involve anymore. Right, so we've got an address, we've got a subvar index, we have the number of things that we're interning, yeah. Right, so intern n is that many. Why do we bother with that? Why don't we just use the pointer array cap directly? Do we ever do a different number? Member n. I'm pretty sure that'll be 1. The member array cap should be 1 there anyway. Okay. We'll leave it for the moment, just because. Okay, but we're not actually going to do we're going to do 2 passes. We're going to do one pass that gets all of the pages, and then another pass that just gets those pages. I didn't explain that very well. We're going to do one pass which finds out which pages we want to actually use, and we're going to do another pass which actually records those pages. Okay. Right, so intern values at address, intern inner value at address. Subvars index. We want to make sure that this is actually a variable. Subvar kind equals sub yes, this does not have that. Okay. Just changing the type of recursion from function recursion to like data recursion has a slightly different API. Actually, that should be fine. I don't think we need to be too persnickety about that. Okay. So we've got our type thing. Oh, right, yeah. That's why it's going to be a problem. Because we need an expression tree. Go away and turn in a value. That can go in there because it's only ever used there. Subvar array member. Okay, I'm going to put the put the flag here. Intern new. And what this is going to do is tag pages to intern, run sorry, I know I keep changing what I'm doing here, which is probably not super exciting, but it's what needs to be done. Okay. Okay. Tag pages to intern. We're going to take a run, and we're going to take maybe like a variable index and a sample index. But there's also going to have to be another step here. Okay, I could just be iterating over the variables rather than the dies here. Yeah. And then after we're done with that, then we need to do the intern tagged pages. Just make this a little bit more concise here. Call it run rather than run data. Pretty sure I need the sample index for that. Okay, so we have a variable index. We are not doing this because that loop is already covered for us. That needs to happen before here. If g.ff intern new. That go away. We clear the function expression. We set the function expression to just have the variable index. Yeah, this seems good to me so far. Search for the type, find the type if it contains a pointer. Now, do we want to do capture before or after that? Probably before. Memory range should be contained within the data recorded in this iteration. Okay, so hey Mongo, hey Dim. Searching through types. I think. Right, so presumably this is going to give us Where do we get... Alright, so we've got... I guess we've got the address from this. Oh, no, I hope I'm not going to just end up remaking this. Damn it. Okay. I guess we can No, we'd have to change all this, won't we? Because we have expert eval, which results in an address, but it does that for data that's already interned, so we can't use it for interning data. Right, but I guess we can just do a version of this that is, this is pretty short. File location is sample index. Yeah, I think we'll do a version of this. Oops. Okay. If valid, summary up inarct is the address, and type for the actual data stored. Yeah. Okay. Export up. Intern export up next. This whole in out malarkey is useful, but change that to mutable just to save a few characters. Right. So that could be the same. It should be the same already. Alright, is that below where we are currently? Yeah. Intern expert up next. That should have already been recorded. Whatever. Expert it takes some run data, an expression, var. That's not used anymore. Okay. So internet from next. Sure, somewhat be kind. Yeah. Yeah, we'll just take the partial. Okay, and then this is really the keystone is using pointers, because we want to get a little bit. We want to just pull in that small amount of data. I guess you may as well record the entire page the first time you see it, because I'm assuming that touching the page, but we only do that for pointers. Let's do the simple thing first and keep it unjammed, and then we'll jam it if we need to. By which I mean basically having two separate concepts in the same loop, as opposed to putting them in different loops. Okay, so we've got dies, got subvars. Interned pointer add sample. And basically what we want is so theoretically, like, we're only really changing this function, but this is the normal version of this is something that gets called a lot, and so I don't really want to add extra indirection that's going to slow it down. Peak, is it? Peak value, peak value. Peak value. So we want to set. I don't. This feels backwards to me. Let's do it the other way around. No, it wasn't. Yes, we're gonna. I'm not entirely sure about this. Adding. That's not really what I wanted to do, is it? Oh no, it is because we do like one more than yeah. Because we've already looked at. I need to check this. Anyway, we. That's what we're modifying. We are taking run handle proc handle, I think it is. We are passing in the previous address. And we're doing size of proc address. So what's the other? What was the other one doing? The other one was doing intern to pointer example. Right, but the next time round we want let's just debug. Yeah, pointer type index. Okay. This all seems reasonable. That seems like a very small number of changes, but I guess we'll try it. We'll just do the same things we did before, which is internal inline expr op. Intern expr eval. We're just doing the same as this. Let's think. Let's think. This is not like the prototypical thing, so let's leave that for later. Actually, I don't know. Okay. It's like the next time we come round. Oh yeah. No, that's fine. Yeah. No, it's alright. Forgot how that worked. That's all fine. I'm just gonna do the same swap here. just generally makes more sense to do the like positive one first. Intern expr up next, and then we're just gonna have a thing that goes through and returns that. Intern expr eval. Excellent. Exprop address equals intern expr eval. Run function of expression sample index. Wait, is this actually using the sample index? Because I guess so. Yeah, that's fine. Keeps it with the same API as the other one, which doesn't hurt. Anyway, so we've got the address, and then we want the size that we want to copy, which is going to be to do with the cap. That thing. Subvar size. I think I want subvar size. Array n subvars address.subvar index dot pointer array cap. Data size. Now, we don't really want to bother with this if it's inaccessible. We only want to do if address.kind equals expr up address. Then we're going to get the data size and data size plus os dot page size -1. Divided by os dot page size. So what we're doing here is just rounding up, basically. So we're adding one less than a full page size, which will then get truncated down. So if it's anything above one, if it's like if it's exactly a page size, it will be a page size, and if it's one or more above page size, it will be the next page size up. Start. I start. Okay, right, so we've got the start address for some data, and we have how big that data is. And so this actually isn't quite right, is it? We want to do something slightly different. Okay. Okay, so we're going to take the address and we're going to go I'm going to subtract from data whichever is smaller of either the page size or the amount that's left. There we go. That's better. Okay, so and then also proc addr plus equals os dot page size. And so we're now just going to add this wait, now is that going to account for weirdly offset stuff? Oh, I'm being an idiot here. I've done this so many times before. It's just getting a bit late in the day, to be honest. Okay, so like the obvious edge case is if we have a 2-byte thing that straddles 2 different pages. So we've got like new pointer last byte equals proc addr plus data size -1. Okay, I think it makes sense to do only the first actual byte needs to be only the first address needs to be masked off for pages, and after that it can all be on exact page boundaries. So we know that we want to add a page here. So what have we called it? Come on, stop being so slow. Right, so it's addr spool map. To intern function obj pages to intern. Insert, we don't need to modify it if it's already there. The address, initial address is adra.proc adra. True. True. Nope, just true. Data size is that. Okay. Last byte is that. Adra.proc adra and os dot page. Do I have page mask as a separate thing, or is I just do that manually? Mask. Yeah. Os.page mask. U point next page equals right. So okay, so we next page is the start address of this current page. We insert it if it's not already there. We set next page plus equal yeah, this is how we do it. Okay. Next page plus equals os.page size. We're checking for os.next page is less than or equal to last byte. That can go there actually. Adra.proc adra plus data size. Next page. Yeah, well, we still have like things to look at. So just to work through the example of when we had, if you have a page boundary, so like data, and then, come on, page boundary, and then more data, and you are referencing that one and that one. So we have proc address is this. the first page, next page is here. Data size is 2, so we add 2, subtract 1. That's the last byte. Next page is currently over here, less than or equal to last byte. We want to add that first. Let's just call it page. So we're now here, and so we've recorded that. That's in the map now, plus a page here, and so we then that is less than or equal to the last byte because it's equal to the last byte. So we record that. We add another page. We're over here somewhere. We're way outside now, and so we stop. Cool. Yeah. Just gotta walk through that one. Okay, so we just do the same here, basically. That took probably longer than it should, but we got there. Should we recurse? Cool. That's quite neat compared to all of the other stuff that's going on. So we wanted to tag pages to intern. That's being done there. And then we're going to intern tagged pages. Yeah. Tag all of the pages that this data that is touched. All the pages that are touched by this data. Tagged okay, so what's this going to be? Internal void intern tag pages run data run okay, we're going to want a function obj because we have the data interning stuff in there. Function obj. I think I'm going to change the name of these to record because intern is kind of slightly different, and record is very obvious, and also allows replay as the obvious mirror to it. But not everything at once. Can't do everything at once. Function object. We're gonna have let's just see what we need actually. Turn. Ah, we need a special case for strings. Yeah. Yeah. Right. Forget that we have that. All right, I'm gonna be back in a sec. Let's finish up, and then I'm gonna go get some food, because it's that time of the day. Okay, so we are going through all of the pages. Let's just get some. Oh no, apparently not. Pages to intern n is the ones we're going for. Size, page index from 0 to n. Dot vowels page index. No, keys. Upointer page address is that. Intern range at sample. Run page address os dot page size sample index. Okay. I need some extra data for that, so let's do scope. Temporary storage. So what's that? Scratch, push size. Scratch, push size, os dot page size. G scratch. Scratch data. Cool. I could actually, if this is what we're going to go with, I can simplify the way that this works as well, which would be easy. That is done, I think. So the one thing we need to modify is this tagging. So if we have an address, great. Is string equals I'm sure I have something for is string. Dwarf type is string. Maybe we should do that. Is string. Dies in a type index. Dwarf.c type is string. Does it do a pass through here? No, okay. Dwarf type pass through dies. Sorry, back for a sec there. That also takes dies subvars subvar addr.subvar index dot type die index. Right, so this determines if a pointer is to assigned characters. If it is, then we assume it's a string. If it points to another pointer, yeah, okay. This is oh right, we actually do recurse. It does pass through anyway. Okay, so rather than go for like a fixed size, because that'll just be maybe I can do this better actually. Right, because this is taking the pointer basically and going down, but if I work starting from the pointer, then I still need to like take the address of the pointer, which is what'll happen with the data tree next. Yeah, which is what'll happen with data tree next. So why not just wait until the expression has both of them in? We can see that up star x per top equals very last function obj expression. Okay, so if x per top equals dot sub var index. Sub var index. Yeah, expression is string is what I want. Expert is, which I can do as a standalone thing, excitingly enough. Internal inline bool expert is str. Expert up expert. It's not really modifying anything. If array len expert is greater than 2, greater than 1, greater than or equal to, and n equals x per n minus 1, so that's the this would be a signed character, so we want to check alright, this is the important one. That's going to stop us accidentally accessing invalid memory. Here's base type. I want this. dwarf die end type die equals the see, these end up everywhere. Dwarf type pass through okay, so we'll pass the end type to that. That gets initialized there. Pointer type -2. Okay, so if pointer type dot tag equals dw tag pointer type consider doing arrays, but then you get weird things happening. Should probably be don't really benefit anything from having that separate. End type dot tag equals dw tag base type, and that then we get the encoding. Cool. Right, so we have the expression as string. Very nice, very nice. So in here, let's just declare that function expert is string. equals is string function of expr dies subvars. And then if is string, do a thing. Otherwise, find all pages touched by this string. Now I have something that kind of does something similar to this already. Peak. I think I have a peak string maybe. Yeah, an AppC. Except we don't want to. I guess we kind of do. Okay, we want buff. That is scratch push size os dot page size. Okay, and then we're going to do os dot peak value into the buff, os dot page size, run dot proc handle, happens when the last byte up is a char. This means we have its address ready. Scratch push size, buff, p-value. No, you want to do something slightly different from what I did before. I guess the question here is going to be, what do we do with pages that don't work? We are kind of doing intern range sample. Yeah, we wanna let's mark them, let's tag them, and then we can actually handle invalid pages later anyway. I think. Do I mean that? I'm pretty sure this handles invalid stuff. Working to the source, into range sample. This bang into get value break, yeah. So it handles that gracefully. So we wanted to just go up here. So we have fully access to this this map or the set. Run.proc handle. We're going to bring in the entire page from the start. Do I want to do this separately at the beginning, or put that as part of the So we're going to get the offset, and that's going to be basically the opposite of this. String address and not. That doesn't need that. os dot page mask. But we need it on the first one, and then afterwards it can be 0. So os dot page size minus string offset. And then we're going to make a... What's the fastest way of finding a mismatch? I have strings.c, I have mismatch. It's a mismatch, string index is mismatch, index of string contains, yeah, string equals string from len page, no, page plus equals os dot page size, yeah, so we'll get rid of that. That can just go as part of the string construction, and that's going to be the local pointer, so buff plus string offset. So we've put some data into the buffer, we get a string from it, and then we check whether if string contains and is string contains a literal 0, then we break. So basically we just keep going until we find keep tagging pages until we find a null terminator or memory we can't access. So we have when it's a string, when it's not a string. I don't need this to be a separate. Oh wait, do I? Strings can't recurse anyway, so we don't need to worry about that. Say data and size. And then tagged pages, we've already accounted for strings, so we don't actually need to do the string thing in the data handling. Cool. Tag pages intern tag pages. See if this compiles. Export op type. I guess that gets done later as well. There's probably a better order for doing these, but I'm not going to figure that out right now. Result run. Calls it run. Yep. Run. Whatever. Recur index. Intern. I'm going to say intern for var. And the important thing is no, it's already done. This map's already been cleared. Vars. Let's push right, yeah. G scratch. Just got to make sure that that flag is on, not past the struct itself. Same again. Same again. If oops, yeah. We're compiling. Let's just give it a quick run, and then I'm going to call it a night. So we need to make sure that we're running it with the thing. Was it intern new? What didn't you like about that? Turn new? No. There we go. Method of interning. Compile. Let's try running that. I'm sure there's probably going to be some errors in this, just because, you know, it's bound to. It looks like we have a an infinite loop, maybe. That's wrong, I think. Where are we? That's probably in here. Let's just Okay, that's wrong then, isn't it? Just run that again. So we have page. Adder.proc editor. It's valid. Yep. Page. Plus equals os page equals. Oh no, I've done doing this the wrong way around. Okie dokie. Okie dokie dokie dokie. Right. That's fine. So what I've been doing, just to show you, here, is say we have a bunch of bits. And then we have a mask that's like this. Whoops, sorry. The mask is like this. You can get the offset within the page by just applying the mask normally. And then everything above the mask, goes to 0. So you get that. So this is, or what we actually want to do is cut off everything inside this mask, which we do with and not. So we're going to do some and not. Yeah, it's just, so actually just to be even clearer, so this is the mask, and then this is not mask, right? So we're anding with that, and so everything on this side gets kept whatever it was before, and everything here gets set to 0. So this is actually the wrong way around. It's quite nice to think of it like as its own operation, but this is really a unary operation on this, on the mask itself. Okay. Okay, let's try that again. Compile. Rerun. So page That looks more like it. Proc address BFF something something something. Page equals FB. What happened to the rest of it? Page size. Okay, 83.4, whatever. Page plus equals page size. 83.5, cool, yeah. And then data size equals some small quantity, 4. Insert. Page plus equals page size. Okay. Header to proc header. Something happened there. Why is this proc header changing? Which header? Okay, it's not. Page. Figure it out. Oh, is it? Oh, is it doing some illicit casting that I don't want it to be doing? That seems quite likely, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, and then it's getting cropped there. You bastards. Casting stuff is annoying. Which means I'm going to change this here, page size. That can be a U. Just for the sake of making sure it's complete. Happily waste a few bytes as it's really only a few bytes. That's going to make it a bit more robust. Avoid stupid errors like that. Connect. Page. That's more like it. Okay, cool. Last byte. Okay. Just didn't last long, did it? Cool. Intern range example. Data size less than data offset. All right, this is yeah, this is what I was just saying before about is that because there's a string, or is that because no, it's not, there's no string here. Okay, we just need to change this a bit, but I'm happy with how that's working for the moment. Then we're getting through. Let's just have a look at the this map. Not that map. pages to intern. So just to keys. Watch pages in keys to. Okay, right. Fine, whatever. So we'll handle invalid pages next time. But until then, thank you ever so much for tuning in. I will be, like I said, I'm streaming a bit more. So unless I come down with the COVID, which is very possible, I'll try and do at least one more stream this week. Until then, you can join the Discord for WhiteBox, which is at chat.whitebox.systems. You can go to the WhiteBox Systems website, whitebox.systems. Follow us on Twitter at whitebox_sys. You could buy WhiteBox and play with the current beta version, and you can do that through the website, or you can go to itch.io, azmr.itch.io/whitebox. But until next time, I shall have to love you and leave you. And yeah, I wish you all the best. Have a great one. I will see you in a bit. RoCatBG, have a nice day. And you, RoCatBG. Right, take care everyone. Have a good one.